doing problem 11 from practice exam 2. So this asks us to find the length of this parametrically defined curve. So we have to remember our equation for finding the length of a curve defined parametrically. So in order to use this formula, we need to figure out the two derivatives here. So dx dt is just 3, and dy dt is just the hyperbolic, 3 times the hyperbolic sine of 3t. Okay? So putting this into the formula, we get L is equal to the time interval that we're given there is 0 to 1, the t interval, I guess. So we're going to get the square root of, let's see, squaring that I'm going to get 9. Squaring the next one I'm going to get 9 hyperbolic sine squared of 3t. Okay, so I can factor a 3 out of that thing, and we'll get the integral from 0 to 1. Factor the 9 out, take the square root of that, I'm going to get a 3. And then what am I left with under the radical? 1 plus hyperbolic sine squared of 3t. Okay, now here we have to, it's kind of maybe tricky to think back about these hyperbolic identities, but it turns out that there is an identity for the hyperbolic trig functions. It says 1 plus the hyperbolic sine is equal to the hyperbolic cosine. And so the identity is actually hyperbolic cosine squared minus hyperbolic sine squared equals 1. Okay, so in fact, I'll put that up here so we know what we're using. It's hyperbolic cosine squared of something minus the hyperbolic sine squared of something is equal to 1. Okay, so if you solve that identity for the hyperbolic cosine, you see that you get exactly what's under the radical here. And this is going to give us the, using that identity, that's going to give us 3 times the integral from 0 to 1 of that turns into hyperbolic cosine squared 3t. And then, of course, taking the square root of that, we're going to get 3 integral from 0 to 1 of just simply hyperbolic cosine of 3t. Okay, and then the antiderivative of the hyperbolic cosine is the hyperbolic sine, and since we've got that 3 there, we'll have to have a 1/3. It will cancel with the 3 there. So we're just going to get, as our antiderivative, hyperbolic sine of 3t. You're going to evaluate this from 0 to 1. So for our final answer here, we're going to have the hyperbolic sine of 3. And the hyperbolic sine of 0 turns out is 0, so that's why we're getting our answer as hyperbolic sine of 3 here, which is approximately 10. Okay.